Stellar, that row. So let's talk. So front side of the note packet is what we talked or what you started yesterday, and then we'll get into the back side, and then we'll finish up on the third page. First off, before we start though, a little bit of a pre-calc team brag. So this is in a video game that's being developed in a college right now, but part of the code that goes along with it is a sine curve, but this, I forget what the name of the program is that this person is developing this game on, but it only reads numbers between 0 and 1. So they had to modify the sine curve to fit in between 0 and 1, so they had to divide the sine curve by 2, and then add 0.5 to it, and it's part of this big long chain for this. And then the video, what it does is, so what that does is it flashes the lights in the ball, just for that. So where am I ever going to use this sine and cosine and tangent stuff? In art school, designing video games. Okay? Right? Which, it also just happens to be Mrs. Hill's child that is developing this down in Georgia. So it's pretty cool. Okay? All right. So let's talk these proofs. Now, yesterday, so we're talking the front side, first page of your note packet. Yesterday, I gave you the proofs, and I said, go at it. And everybody tried to prove them using the formula, using the proof. Can't use the proof to prove the proof. Okay? You got to use something else. So what you should have done is you should have rewritten sine of 2u here. We'll only do this first one on this page. You should have rewritten sine of 2u as sine of u plus sine of u. Then that would become sine of u cosine of u plus cosine of u sine of u, and then that would become 2 sine of u cosine of u. So then, now you can use that one because you've proven what it is. And you should have done that with all of these other ones. Okay? So here, cosine of 2u would be cosine of u plus u. So then that would be cosine u plus, oh, excuse me, should be minus because this one is opposite. Minus sine u. And then that becomes your cosine squared of u minus sine squared of u. Then you're going to take that one and use it to get a different one. So you're going to use it to get this one. Then you're going to take that one, which you get, you're going to use that, or you can start back again here with, at the top and go back and do those two. Okay? And then tangent is the same way, okay? Where you start with the 2u is u plus u. And so you should have gotten that, all of that done last night before class today. Then you had to go back onto here. Now I want to do number 1 here together because it's kind of a, I don't want to say the tricky one, but it's a different one. So now that we have the formula for sine of 2u, which is number 21 on your sheet, we can rewrite sine of 2x as 2 sine of x cosine of x equals sine of x. What do you want to? You super duper really truly want to do something here, but you can't. What do you want to do? You want to divide by sign. We can't divide by sign. Okay? So what can we do if we can't divide by sign? Yes. Because then if I'm dividing by sign, then I'm adding a denominator where a factor could be 0, which makes my equation not possible. So we can't divide it. It also gets rid of whatever factor that sign wants. Okay? Yes, ma'am. Okay. What do you got? So we're going to subtract sign from both sides. So if I subtract sign from both sides, then I get 2 sine of x cosine of x minus sine of x equals 0. Now what can we do? Now we can factor out a sine, yep. Okay. So if I factor out a sine, then I'm left with sine of x times 2 cosine of x minus 1 equaling 0. Now that I've got it in factored form, now what can I do? Set those equal to 0. So where is sine of x equal to 0? 0 and pi. Where is 2 cosine of x minus 1 equal to 0? Because that's where cosine of x is equal to 1/2. And what did you say? Yep. And together, those two are the answers. Okay? Let's do one more. I'll let you pick which one we want to do. And I'd say it better be number 5. Okay? Because it's sine of 3x, right? Okay? So what can we do with sine of x plus sine of 3x? So sine of 3x we're going to turn into what? Okay? So I think this is what you're saying. Sine of x plus sine of the quantity 2x plus x equals 0. Is that what you were saying? Because that's what I heard. Okay? Like that. Now what? No, I cannot. So which formula are you applying? Which one? 19? Okay, because you could also like apply it to 21 too. That's why I wanted you to be specific on which sine one you were applying. Okay, so we're applying 19 to this part, the second part, right? Okay, so then this becomes sine of x plus, I'll switch colors with this one now, then this would be sine of 2x cosine of x plus cosine of x sine of 2x. Wait, no, I said that wrong. Nope, yep. Cosine of 2x sine of x. Like, wait a second, I was getting the same thing in there. Yeah? All right? And that still is equal to 0. Okay? Now what? into number 21. Okay, so that this would become sine of x plus 2 sine x cosine x times cosine x, right? Okay. Third one, the one with just the signs. Okay. And that's still all equal to 0. Clean it up a little bit, right? Yeah? Okay. So if I clean this up a little bit, then I've got sine of x plus 2 sine of x cosine squared of x plus sine of x minus 2 sine cubed of x. Second one, 7b. No. No. Cosine squared is 7. It's formula number 7, because it's not cosine squared of 2x.
Oh, yeah.
Yeah. Yeah. You were saying it right, you just identified the wrong one. Can I combine the two? Can I go 2 sine of x also? These two? Can I do that? Okay, all right. And then plus 2 sine of, and then this is, you said 1 minus sine squared. Okay. So then that's going to be 2 sine of x plus 2 sine of x minus 2 sine cubed of x minus 2 sine cubed of x. Okay, what do we got? Okay, now what? Factor what?
You can factor sine x.
4 sine x? Yep. That was kind of aggressive, I'm not gonna lie to you. So then it's what?
1 minus sine squared.
1 minus sine squared.
Get in there.
Okay. You tell me. Okay. But could you? We'll put a bookmark on that one, and we'll come back to it after we get done with it, okay? And we'll see if we get the same answer. Okay? For sine of x equals 0, that means what? Sine equals 0. Where does sine equal 0? Okay? 1 minus sine squared of x equals 0 means? No. No.
Sine equals minus 1.
Because it's 1 equals sine squared of x, so it's plus or minus 1 equals sine of x. Positive 1.
3 pi
Pi over 2. Negative 1.
3 pi.
Okay? Back to that bookmark shape. If we had switched it to cosine squared equals 0, then it'd be where cosine equals 0, which would be same thing, pi over 2, 3 pi over 2. So either way. Yep. And there's your 4 answers. I love that problem. I do. So fun. It takes everything and it ties it all into one problem.
Yeah, everything on the
There's no way you can just look at that problem.
Nope, there is no way that you can look at any of these problems and go, that's what that is. Yep, you gotta do all the work behind it. Yep. Oh, us mean old pre-calc teachers, I tell you. Alright, let's go to page 3. Okay? So, page 3 says, now we've got half angle formulas. So yesterday was double angle formulas, now we've got half angle formulas. Okay? Sine and cosine. Now these are a little, you got to pay attention to what's going on with these. So, with these formulas, okay, yes, there is a plus or a minus out in front of them, but that does not mean that you get 2 answers every single time. You have to do some thinking first. Okay? It is not plus or minus in your answer. It is either positive or negative. It's one of them, not both of them. Now, here's how you go about figuring out if it's positive or negative. You look at angle U. Wherever angle U is, whatever quadrant angle U is, that's going to tell you the positivity of your half angle. So for instance, what I mean is, if angle U is in quadrant number 2, okay? If angle U is in quadrant number 2, then the sine is positive and only positive. With me? Cosine's negative, tangent's negative. If angle U is in quadrant 3, then tangent is positive, and only tangent is positive. If angle U is in quadrant 4, then cosine is the only one that's positive. In quadrant number 1, they're all positive. Okay? So that's something that you have to keep in mind with the half angle. You might want to write that right next to numbers 24, 25, and 26 on your purple sheet. Okay? So let's try some here. Pick one. Well, there's 6 of them. Pick one of the 6. I don't care which one. Number 1. Straight up number 1. Okay. So the sine of 15 degrees could also be the sine of 30 degrees divided by 2. Yes, ma'am. Just like yesterday, we're finding an angle that's on the unit circle. And 15 is not. We can find it. But 30 is. Okay? So the sine tells me that I'm going to be using number 24. Yes? 30 degrees. In or at u equals 30 degrees. Is my sign positive or negative? Positive. So that means that this then is going to be positive. Then it says we need a big square root of 1 minus the cosine of 30 degrees, all divided by 2. Well, what is the cosine at 30 degrees? Do you want to keep change flip now, or do you want to keep change flip later?
Change it now.
Now? Okay. So if I keep change flip now, then this would become I didn't really give you enough space to work on this. Clearly I blame myself. So we'd have the square root of 1/2 minus the square root of 3 over 4. Need me to write that out? That's fine. That's why I asked the question if we wanted to keep change flip now or later. You are in the later category. Yeah. So then this would become the square root of 2 minus the square root of 3 all over 4. Speak now or forever hold your peace.
Is that just the answer?
Denominators and then subtract.
Because it's all of that is underneath the square root. We're still we're tap the brakes. Stop. Let's get through this step first before you go on to the next one. That's what I'm asking. Everybody good with this step? What? I'm just making sure everybody's good with it.
It's like we're
No,
wrong.
no, it's right. It's 100% right. I'm just making sure because I'm making a bunch of assumptions that you guys are paying attention and you know what I'm doing. So I want to make sure that everybody is understanding what we're doing. Because otherwise I'll show it. Okay? So then this could be that, correct? I know it's what you said. I'm slowing us down, making sure that everybody's good. No, I didn't say no to you. I was saying no to him because he was trying to get to the answer while I was still trying to make sure everybody else was on board. Okay? So then our final answer is, that's my question. Can we have a square root in a square root?
Square root 2 minus the cube root.
No.
Is it 2 minus?
It is literally just that.
What
Yes.
is square root do?
It's also square. Yeah, you find the answer to square root.
The problem is that if it were multiplication, yes, then we could go to a fourth root. But because it's addition and subtraction inside of there, it's got to stay like that. So that is what the sine of 15 degrees is equal to. Yeah. Let's pick one more. Let's pick one this time with pi in it.
Let's do tangent one, number 5.
Number 5?
Yeah.
That's a good choice. Okay. Make sure you've got the lined up. Okay. All right. So tangent of 7 pi over 12. Okay. So that is going to be the tangent of what divided by 2?
14 pi.
Nope.
7
Nope.
pi over 6.
7 pi over 6.
Oh, yeah.
What's the quick way?
Take the denominator and divide by 2.
Exactly. Take the denominator and divide by 2. And that's what you're going to get if you would divide the whole thing by 2. Okay? So that's 7 pi over 6 then. Now, which of the tangent formulas, we've got 3 of them to choose from. Which one do you want to use?
Let's do the first one, the sine of u over 1.
Does it matter which one we use?
Actually, let's do the second one. 1 minus
Why would the second one be better?
because there is the 1 on top and
There's just a.
Because the sine of u is just going to be a fraction, right? So rather than have to deal with adding it, so like the 1 minus the 1 plus a fraction in the first one, we could just go to the singleton fraction in the second. Yep, I would concur with that. Let's it's the KISS strategy. Keep it simple, students. I thought I was going to say stupid. Not rules. Keep it simple. Yeah. All right, so we're using the second one. So that says that we then have the 1 minus the cosine of 7 pi over 6 all over the sine of 7 pi over 6. What is the cosine at 7 pi over 6? What is the sign at 7 pi over 6?
Negative.
Yeah. But this would be dividing by negative 1/2, so it would be the same as multiplying by negative. Maybe get that one in there. Okay? Do you want to keep change flip now or later?
I say we do it later.
She flat out told you to shut up. Now or later?
Do I deserve this?
Which one's easier?
I mean, what did I
I don't
do?
even know that one. I don't even know. Keep going.
Well, I would like it first to make it 1 plus.
Okay. Sure. Because it's minus and negative. Uh-huh.
Oh,
So back to that keep change flip now or later? Now. Okay, let's go now. So then that's going to be 1 plus the square root of 3 over 2 times what? Times negative 2? So that's a distributive then, right? Okay. 1 times negative 2.
-2.
Square root 3 over 2 times negative 2.
-2 times the square root of 3 over 4.
Negative 2 times the square root of 3 over 2.
Negative square root of 3.
I like negative square root of 3 better.
What is the negative?
Sadie made us go, instead of minus and negative, she made us go plus. So blame her. No, you did good math. And you didn't tell Joey to shut up.
I have a question.
I got an answer. 78.
Gotcha.
I got a 2 plus for the equal. It still equals the same thing.
No, it does not. See, because this one would be negative.
Yeah, 'cause you do like.
But if I were to multiply that by a -1, it would equal the same thing.
But that's not what the answer you gave, though.
Absolute value, though.
It's not an absolute value thing. Yeah. Yeah. So 7 pi over 12. Might have to get some. Just grab some napkins. 7 pi over 12. Where is 7 pi over 12 on the unit circle? What quadrant?
That's gonna be the same.
It's going to be the second quadrant, right? What is tangent in the second quadrant? Negative. So Joey, back to yours. You go 2 plus the square root of 3. That's a positive number. Can't be in quadrant 2 where this angle is.
I saw what I did wrong. I forgot about the negative. Where that 2 is.
I get it. I get it. Okay, so now what's going to happen is I'm going to hand out to you this wonderful worksheet that is now on a colored piece of paper. So what does that mean?
We're turning it in.
That means you're turning it in. There is only 6, oh, no, I lied, there's 8 questions on this piece of paper, okay? But if you'll notice, there's lots of room to work. Why? These problems
They take 5 ever.
take up space. They do take 5 ever.